In the world of software development, APIs are increasingly important for modern applications. APIs connect systems, enable data exchange, and provide smooth automation. In this video, we address the critical topic of API design and why it's essential to avoid binding your API to an ORM entity model. Let's uncover the pitfalls and discover the paths to more flexible, maintainable, and powerful APIs. Object relational mapping is a technique that allows developers to interact with a relational database through object-oriented programming. It tries to bridge the gap between the world of object-oriented code and the relational databases and allows you to work with database records as if they were objects in your code, simplifying interaction with the database and reducing the need for raw SQL queries. For example, Doctrine and API Platform is able to automatically expose entities mapped as an API resource through a REST API, supporting CRUD operations. To expose your entities, you can use attributes and YAML configuration files. Binding your API tightly to ORM entity models often results in a CRUD-based API, where much of the logic is pushed onto the client side. ORM entity models tend to closely mirror the database schema, focusing on data storage and retrieval. When your API is tightly bound to these models, it becomes primarily concerned with CRUD, create, read, update, delete operations, reflecting the basic database operations. When you bind your API tightly to an ORM entity models, you mix database logic with API logic, which can make your code harder to maintain. APIs should not only provide data, but also encapsulate business logic and application-specific rules. However, when your API is tightly coupled to ORM entity models, the logic for data manipulation gets often pushed to the client side. Clients must perform complex operations by orchestrating multiple CRUD requests, leading to an anemic API with minimal business logic. With the API mainly responsible for exposing database operations, clients such as web or mobile applications must handle data validation, business rules, and complex data transformations. This puts the burden on the client-side code, making it more complex and less maintainable. CRUD-based APIs may result in inefficient data transfer between the client and the server. Clients often need to make multiple requests to the API to perform a single logical operation, leading to increased network overhead and slower response times. Inefficient ORMs can lead to performance issues that are difficult to optimize. For example, the N+1 problem is a common problem when using an ORM. It can happen when an ORM retrieves a collection of entities and then makes additional queries for each entity to retrieve associated data. In this code, for each user, a separate query is executed to fetch the associated posts. This results in a large number of database queries and less performance. To fix the N+1 problem, developers can use eager loading to the rescue. This means the ORM can then retrieve data in advance. With eager loading, the associated data is retrieved along with the parent object. This is more efficient when loading data, but the data is loaded whether the data is used or not. The problem with eager loading is that it is up to the developer to tell the ORM when to perform eager loading or not. But it is far too easy to forget setting up eager loading, and it requires knowledge to perform eager loading only when needed. It becomes even harder with several developers. A CRUD-based API is less reusable because it exposes the underlying database structure directly. Changes in the database schema can significantly impact your API, leading to challenges when adapting to evolving requirements. This tight coupling makes it challenging to modify or extend the API without affecting client applications. Handling complex database queries can become cumbersome when tightly bounded to ORM models as well. While an ORM and proprietary platforms can be helpful at the beginning, They can eventually restrict your database options and create heavy reliance on third-party providers in the long run. To overcome these limitations and create more robust and maintainable APIs, it's essential to abstract the API layer from the database layer and introduce a service layer that encapsulates business logic. This separation allows you to design APIs that provide meaningful high-level operations, reducing the client's burden of handling low-level CRUD operations. Separation promotes cleaner, more maintainable code and better performance by minimizing unnecessary data transfers between the client and server. When different teams or developers work on different modules, they can optimize their components at the same time. Use case specific queries leads to lower overhead in database communication and data transformation, resulting in better performance. Separation helps in identifying which parts of the system are frequently accessed or require real-time data and which can be cached. Caching can significantly improve performance by reducing the load on critical components. The choice of caching strategy depends on your application-specific use cases and performance requirements. If you need, you may integrate other data sources such as NoSQL databases or external APIs. Implementing more separation involves organizing your software into different layers, such as an application layer with controller classes to handle HTTP requests and responses, a domain layer with service classes for the business logic, and the persistence layer using repositories for interacting with the database. Repositories are responsible for handling data access operations, including reading, inserting, updating, and deleting data in the database. They provide a clean, domain-specific interface for accessing and managing data. This approach provides a clean separation between your application's business logic and data storage. A service class contains the application's business logic and orchestrates the execution of use cases. It often relies on repositories to interact with the database. This separation ensures that application rules and operations are maintained independently from the API or persistence layer. A controller, like a single action controller, handles the HTTP request and response and invokes a service method designed for this specific use case. This helps to keep the codebase well organized and focused on a single task. Depending on your framework, you may also need to define a route that maps the HTTP request to the corresponding controller action. In conclusion, binding your API to an ORM entity model can lead to various pitfalls, while separating them brings a lot of benefits. I encourage you to adopt a decoupled approach for better API and software design. Okay, thanks for watching. If you have any questions or comments, please write them in the comment section or reach out to me directly.